All right, so you're here with us because you really want to get to the heart of things. You don't want to wade through all the noise and the jargon and the endless details.
Yeah, absolutely.
You want to get straight to what matters, and that's exactly what we're doing today on this deep dive into the world of quantum computing.
Right.
You shared some really fascinating material with us from Kenton Patterson over at Future Tech Wise, and our goal today is pretty straightforward.
Yep.
We want to extract the real core, the essence of what quantum computing is and why it's potentially going to have such a huge impact on all of us, really.
Exactly. And I think the key here is we're not trying to give you like a physics lecture.
Right.
We're not going to go super deep into the weeds of the science.
No.
We want to kind of distill those crucial insights from Patterson's piece and give you a real clear understanding of this field and, why everyone's so excited about it.
Okay, perfect. So let's jump right in. Quantum computing. It sounds so advanced.
It does.
But what fundamentally makes it different from the computers that we're using right now, like right in front of us?
Yeah, so the core difference lies in how they process information, at that really basic level.
Okay.
So your laptop, your phone, whatever you're using right now, it uses bits.
Right.
Which are kind of like a light switch. They're either on or off, 1 or 0, it's a definite state.
Right.
Quantum computers use qubits.
Okay.
Now, what's really revolutionary here is that a qubit can exist in a state of both 0 and 1 simultaneously.
Okay.
This is what we call superposition, and, it's kind of a mind-bending concept.
It is.
But think of it maybe like a dimmer switch.
Okay.
You can have it anywhere between fully on and fully off, or even a combination of both at the same time.
A dimmer switch that's both on and off at the same time?
Yeah.
That's a little tough to wrap my head around.
It is a bit counterintuitive, but that's where that power comes from.
Okay, so how does that translate into actual computing power?
Well, it's precisely that both-at-once aspect that unlocks this huge potential. Because a qubit can hold multiple possibilities at the same time.
Right.
A quantum computer can explore, tons of potential solutions to a problem all at the same time.
Okay.
And Patterson talks about this as quantum parallelism. And a good way to maybe visualize this is think about a maze.
Okay.
A classical computer would have to try each path one by one.
Yeah.
But a quantum computer, thanks to superposition, can explore all the paths concurrently.
Wow.
So it can find the exit way faster for certain types of problems.
So it's not just a faster way of doing it. It's it's on every path at the same time.
Exactly.
That's incredible.
It's a completely different way of approaching a problem.
Yeah, it is a game changer. Now, Patterson also talks about something called entanglement.
Yes.
What's that all about?
So entanglement, it's another one of those kind of mind-bending quantum phenomena.
Oh, okay.
It's like imagine 2 of our quantum dimmer switches, right? Our qubits.
Yep.
They're linked together in this really peculiar way. And once they're entangled, they share the same fate, no matter how far apart they are.
So no matter how far apart they are, they're always connected.
Exactly.
Wow.
So if you measure the state of one of those entangled qubits, let's say you find it's in a 0 state.
Okay.
You instantly know the other one's in a 1 state, or vice versa, depending on how they're entangled.
So you instantly know what the other one is.
Yeah, it's like this deep interconnectedness.
Okay.
And it lets quantum computers do these super complex calculations by coordinating the states of multiple qubits in this very, sophisticated dance.
So interconnected, exploring multiple possibilities simultaneously.
Yeah.
Patterson describes quantum computers as thinking more like nature itself.
He does.
That's a really interesting concept.
Yeah.
It's very different from the step-by-step logic of our current machines.
Right. Classical computers are very linear.
Yeah.
They go step 1, step 2, step 3.
One thing at a time.
But quantum computers, by using these quantum principles,
Right.
they can navigate a much wider landscape of potential solutions all at once.
Okay.
So they're really uniquely suited to tackle these problems that are just way beyond even today's most powerful supercomputers.
So these are problems that are impossible for our current computers to solve.
Pretty much.
Yeah.
For many of them, at least in a reasonable amount of time.
Okay, so we're starting to get an idea of what quantum computing is.
Yes.
But the big question is, for you, the listener out there,
Yeah.
why should you care?
Right.
What are the real-world implications of this technology? How is this going to affect our everyday lives?
That's the crucial point. And I think Patterson lays out the potential really well.
Okay.
Let's start with something that, touches everyone. Healthcare and drug discovery.
Okay.
So developing new medicines is a really long and expensive process.
Yeah, it takes years.
Years, exactly.
Right.
And what's really exciting about quantum computing is that it has the potential to really speed this up dramatically
Wow.
by accurately modeling molecules and proteins.
Oh.
So imagine being able to simulate how a potential drug interacts with the human body
Right.
at the atomic level.
Wow.
You could predict its effectiveness, any potential side effects,
Okay.
and do all of that in a fraction of the time it takes today.
So we're talking about instead of years, maybe weeks.
Potentially.
Yeah.
I mean, this could really revolutionize how we discover and develop treatments, life-saving treatments.
So that is incredible. Patterson also talks about the potential for sustainable materials.
Yes.
How can quantum computing help us with that?
Well, we always need, stronger, lighter, more environmentally friendly materials.
Of course.
And designing these materials at the atomic level, it's incredibly complex.
Yeah.
It involves understanding all these interactions between atoms.
Right.
But quantum computers, with their ability to explore these vast possibilities and model these interactions with incredible accuracy,
Yeah.
they could help us discover completely new materials
Wow.
with properties we can't even imagine right now.
Wow. So it's not just about, making our current materials a little bit better. It's about discovering entirely new material.
Exactly.
Wow.
Think stronger, lighter alloys for cars and planes, or even biodegradable materials, that we design from the ground up.
So a whole new world of materials.
Exactly. A whole new world.
That is amazing. I also saw finance on the list of potential applications.
Yes.
How does quantum computing fit into that world?
Well, the financial world is all about analyzing huge amounts of data, right?
Absolutely.
To make predictions and manage risk.
Right.
And quantum computers, they could bring a whole new level of sophistication to this analysis.
Okay.
You could have more accurate market predictions, better fraud detection by finding those subtle anomalies,
Right.
and even developing more optimized investment strategies.
So it's all about, sifting through this massive amount of data to find patterns that we can't even see right now.
Yeah, exactly. It's like finding a needle in a haystack, but doing it super fast.
Wow. And of course, we have to talk about AI and machine learning.
Right.
This is something we hear about all the time.
All the time.
How does quantum computing take that to the next level?
Well, current AI algorithms, they're powerful, but they're limited
Yeah.
by the computing power that we have.
Right.
Quantum computers could give us this massive leap in processing capability.
Okay.
So we could train much more complex AI models
Okay.
and do it way faster.
Right.
And that could lead to breakthroughs in areas like, natural language processing, image recognition,
Right.
even developing truly intelligent systems
Yeah.
that can tackle these super complex problems with more nuance and personalization, as Patterson says.
So it's like giving AI a turbo boost.
Exactly.
That's exciting, but it also raises some questions, particularly when we think about cybersecurity.
He does.
Patterson mentions this kind of double-edged sword there.
Yeah, so cybersecurity is an area where quantum computing presents both a challenge and a solution.
Oh.
On the one hand, a powerful enough quantum computer could theoretically break a lot of the encryption we use today.
Right. That underpins all of our online security.
Exactly. Yeah, so that's a big vulnerability.
Right.
But the development of quantum computing is also driving research into quantum-resistant encryption.
Okay.
So new ways of encoding information that are hopefully unbreakable, even by a quantum computer.
So it's like this back and forth.
Yeah, it's a race, a technological race.
Yeah, like cat and mouse.
Exactly.
And finally, we have logistics.
Yeah.
Now, it's not immediately obvious how quantum physics connects to something like, delivering packages.
Right.
But how does it...
Well, if you think about logistics as this massive optimization problem,
Okay.
then the connection becomes a bit clearer.
Right.
So think about all the variables involved in global shipping routes, airline schedules, or even just delivering packages in a city.
Yeah, it's incredibly complex.
Incredibly complex. Exactly. And quantum algorithms are actually really well suited to finding the most efficient solutions to these kinds of problems.
So they can sort through all of that data and find the best way to do things.
Yeah, and that could mean huge cost savings, less fuel consumption, and more streamlined supply chains.
So from, revolutionizing medicine to designing these advanced materials, transforming finance, supercharging AI, securing our digital lives, and even optimizing everyday things like logistics,
Yeah.
the potential reach of quantum computing, it seems almost limitless.
It does. It really
It's
does.
not just theoretical science anymore. It's a tangible impact on our lives.
Absolutely. And Patterson really emphasizes that this isn't some distant future technology.
Right.
It's happening now.
Yeah.
There's active development and exploration of all these applications.
It's really exciting.
It is. And towards the end of the piece, he shifts to this really inspiring perspective.
Yeah, he talks about a message of hope and possibility,
Yes.
especially from his point of view in Aotearoa, New Zealand. It's not just about the technical specs. It's about the mindset that this kind of innovation fosters.
Yeah, and what I find really insightful is his focus on cultivating, bold and innovative thinking.
Okay.
He sees quantum computing as this kind of catalyst
Right.
to remind us that there are always new ways to approach challenges.
It's about, being curious, questioning assumptions, and embracing these seemingly impossible ideas.
Exactly. And he highlights some initiatives in New Zealand aimed at fostering quantum education and research.
Yeah.
And he sees that as crucial for the nation's future, in this rapidly evolving tech landscape.
He's really framing it as an invitation to think outside the box.
He is.
To not be intimidated by complexity, but be energized by the potential for breakthroughs.
Absolutely. And that emphasis on, nurturing young talent, especially in a place like New Zealand.
Yeah.
It speaks to this really forward-looking vision of, co-creating the future.
Absolutely. So to bring it all together, it seems like quantum computing isn't just about building faster machines.
Yeah.
It's a fundamental shift in how we process information.
Yeah.
And it unlocks the potential to tackle problems that we thought were unsolvable.
Right.
And as we've explored, the implications are massive.
They are.
They touch almost every aspect of our lives, from our health to the environment, the digital world.
It's really transformative technology.
It is.
And I think Patterson's insights really highlight that.
Absolutely.
It has the power to redefine what's possible. It's paradigm-shifting computation.
So as we wrap up this deep dive into the quantum realm,
Yes.
I want to leave you with a final thought to consider.
Okay.
What problems, what currently impossible problems?
Right. The ones that seem totally beyond our reach.
Exactly. The ones that seem impossible right now.
Yeah.
Might become solvable with these continued advancements in quantum computing.
That's a great question.
Think about the far-reaching implications, the potential for discoveries that we haven't even begun to imagine.
It's exciting to think about.
It is.
It really is.
It's not just about, faster calculations. It's about opening up an entirely new landscape of possibilities.
Absolutely. It's a whole new world.
It really is.